Alright, so this lab we're talking about titrations, acid-base stuff, and the big goal of the lab is to figure out which antacid that we use is the most effective to neutralize stomach acid, right? So a little bit of background. Basically, when you're eating and everything, you have a concentration of hydrochloric acid in your stomach that gets high, and you have heartburn and indigestion, which may occur. Basically, these antacids are going to be used to neutralize that stomach acid. Right? A lot of them are going to use calcium carbonate to react with the excess hydrogen atoms and thus re-neutralize the pH in the following way. So you have your calcium chloride, or calcium carbonate, reacts with this H+, and you get this HCO3-, which can then react again with another H+, and you form this situation going on right here. So just in that way, your antacids are going to react and neutralize the acidic base. So the big goal for this lab, we're going to investigate the effectiveness of different antacid tablets, and we're going to be able to determine the most effective antacid available. So just a word on pH. We're going to talk about an acid. That's a chemical that donates the proton. The base is the chemical that accepts the proton. We have this following relationship. You have hydrochloric acid, sodium hydroxide. You're going to have hydroxide accepting this hydrogen and forming H2O. You're going to have sodium and chloride getting together and forming a salt. Or if we do the net ionic equation, we're going to have H plus OH minus going to H2O. Right? So you have this H plus atom. This H plus atom is, when we're talking about pH, what we're talking about. You can see over here on this table that if we have a pretty high concentration of H+, relatively speaking, this number is way higher than this number. We have a pH of 1, right? If we have just 1 order of magnitude less, we have a pH of 2. 1 order of magnitude less, 3, 4. So each number on this pH scale is actually an entire order of magnitude. It's 10 times larger. So a pH difference of 1 to 2 is actually 10 times larger. Right? And we can see the inverse is the OH minus activity. We can see that when we have a lot of OH minus, we have a very high pH. When we have very little OH minus, we have a very low pH. The exact same things going on, but in the opposite way with the H plus atom. In this situation right here, again, go back over here, we can see that HCl is the acid, NaOH is the base, because the hydrogen atom is given by hydrochloric acid and accepted by the OH to make the water. And again, as this reaction goes forward, the pH of the solution is increasing because of this hydrogen ion is being used up. We're having this free in solution, we're using it forming this, so we don't have as much H+, so our pH is moving up. Right? Now when we're talking about titration, which is what we're going to be doing, titration is the slow addition of one solution of a known concentration, it's called the titrant, to a known volume of another solution of unknown concentration until the reaction reaches neutralization. This is often indicated by a color change. So what are we talking about? We have like an acid of unknown concentration sitting in this flask right here. And then we have a base in here that we know the exact concentration of. And we're going to slowly add this base into this acid until it's neutralized. And as we slowly add the base, our pH is slowly going up, just like we saw before. We have these free H plus atoms over here. We slowly add the base, and as these disappear, our pH is slowly going up. Until you get to this point, the equivalence point happens, and you have used up all the moles of acid that are there. All the H plus is gone, and so as soon as you add a little bit more base, you turn this really basic solution. It doesn't take very much more, and then you kind of steady out up here. So what we have right over here is just written. We have HCl reacting with sodium hydroxide, forming this thing. We start with an unknown concentration of HCl in here. We don't know how much is in here. But as we add NaOH, the HCl is neutralized and the pH goes up. At the equivalence point, all of the acid has been neutralized. And here's the important part that we need to focus on. It's a 1-to-1 mole ratio, and it's all the moles of NaOH that we added. Remember, we know the concentration of this, and we know how much volume we added. We can get the moles. The moles of NaOH added equals the moles of HCl neutralized. So how do we find the concentration of this that we don't know? Well, we know the moles that are neutralized, because we know the moles of NaOH we added. Moles neutralized divided by whatever volume we had down here. So HCl concentration is the moles neutralized divided by the volume. Super simple. Now when we talk about week 1, what we're doing, we're going to determine NaOH concentration. In week 1, we also determine the concentration of an NaOH solution by titrating into a known KHP standard solution. In week 1, this is really kind of just a practice to get good at titrations. This is the protocol that we have. You're going to weigh out 1.3 to 1.5 grams of KHP and dissolve it in about 15 mils of water. And you're going to want that water boiling, but we'll talk about that in class. Then you're going to add 2 to 3 drops of phenolphthalein, which we've used before. We're going to add that to this KHP solution. Okay? Then we're going to take note of our initial volume of NaOH in the burette, and then we're going to begin dripping NaOH from the burette into this KHP standard solution. And as soon as the color changes pink, the reaction is over. We don't want to add any more NaOH. Remember, the phenolphthalein is going to turn pink in a basic solution, right? Or the way we can think about it is that the phenolphthalein solution turns pink as soon as all of the KHP, or the acid, but it's KHP in this case, has been neutralized. So as soon as all of this has been used up, it turns pink, and you see this color going right here. Right? You can kind of see it slowly change in this one over here. So, how do we figure out what our concentration of KHP is? Well, let's look at, we have this reaction going on between our sodium hydroxide and our KHP. So let's say I dissolve 1.5 grams of KHP into 50 milliliters of water, and I titrated that solution with 65 milliliters of an unknown NaOH solution until the KHP solution turned pink. What's my concentration? Alright, so remember, at the equivalence point, right when we stop the reaction, all the KHP has been neutralized. And based on this 1-to-1 mole ratio right here, the chemical equation, my moles neutralized of KHP is equal to the moles of NaOH that I added. So how many moles of KHP did I neutralize? Well, I had 1.5 grams. I'm going to divide that by the molecular weight, which is 204.23 grams per mole. And that gives me moles, 0.0073 moles of KHP. Again, 1-to-1 mole ratio. So I have 0.0073 moles of NaOH. That was added when the titration ended. Right? So I added that many moles. But now, how do I get concentration? Well, I have moles. What volume did I use? It took 65 milliliters of the unknown solution to do it. So I take my moles divided by how many liters I used. There's my concentration, 0.113 molar. And it's just that simple. The math isn't super hard, but there's a good example. That's pretty much exactly what we're doing. These are not the numbers that we're going to be using, of course, but that's an example of how we do it. So week 1 protocol. We're going to be performing 3 trials. You're going to want to clean your burette with really hot water at least 3 times. I'll explain what this is about later. We're going to rinse the burette with the titrant, the NaOH. We're going to fill it with the titrant to about the very top. Make sure we don't have any bubbles in the tip or in the tube. We're going to record our initial volume. We need to make sure we know that. We're going to add indicator to the analyte, which is our solution to be titrated, which is the KHP. And we're going to titrate. And then we're going to go till it turns purple. And we're going to stop it immediately, take the final reading. Okay, because we're going to need to know our initial volume and our final volume. We're going to calculate the concentration like I showed in this last slide right here. Our volume added is V final minus V initial on the burette. Pretty simple, right? For week 2, it gets a little more complicated, but same exact idea. We're going to know the concentration of the NaOH solution, and we've become experts in titrating already, because we've done a whole week of it, right? At this point in week 2, you're going to start by you're going to crush up these antacid tablets with your mortar and stone that you have. And then to that, you're going to add 1.5 molar HCl. Right? So you're going to dissolve this antacid in the HCl. And remember, you have this reaction going on, or this type of reaction going on. You may have sodium carbonate instead of calcium carbonate. It'll be a little different, but same idea. The acid will be neutralized in part by the antacid tablets that you crushed up. Right? So after this reaction happens, you're not going to have any more antacid tablets, but you're going to have some leftover acid left over in that beaker. So what you're going to do, you're going to bring that up here, and you're going to titrate it with the NaOH. You're going to titrate the excess acid that the antacid tablets couldn't neutralize, right? So whatever's in here that's being titrated is stuff that's left over after the antacid has done its job. So how are we going to figure out what we do here? Okay, let's say we added 20 milliliters of a 1.5 molar hydrochloric acid solution to our antacid tablets. After the antacid tablets neutralized all the HCl they could, 5 milliliters of 1 molar NaOH was used to titrate the remaining HCl. So how much hydrochloric acid did the antacid tablet neutralize? How do I figure this out? Well, we know exactly how many moles of HCl we added to the antacid. How? Because we added 1.5 molar hydrochloric acid and we added 20 milliliters. Multiply those together, we get 0.03 moles of hydrochloric acid. Now remember this equation that we had going on. It's a 1-to-1 mole ratio of hydrochloric acid to NaOH. So what does that mean? It means that the moles of NaOH added at the end of the titration, at that equivalence point, is equal to the moles of hydrochloric acid that was left over after the antacid neutralized all of the hydrochloric acid that it could. So we added 5 milliliters of 1 molar NaOH. So 1 molar times 0.005 liters equals 0.005 moles, which equals your moles of leftover HCl. So right here, right, we added 0.03 moles of HCl to the beaker, right? This is our total volume of HCl that we added to the antacid tablets. And over here, based on how much sodium hydroxide we added to the beaker when we were titrating, this tells us how much is left over, right? So remember from before, our total added is 0.03 moles. Our moles neutralized by the antacid is the moles of HCl we added minus the moles that were left over after it worked, right? This moles that are left over is equal to the moles of sodium hydroxide that we titrated with, right? So the antacid neutralized is 0.03 minus 0.005, which equals 0.25 moles, or as we're going to say, 25 millimoles. Crap. Alright, there we go. So, now, with this situation, we would know we neutralized 25 millimoles of hydrochloric acid with our antacid tablets. What we'll end up doing is we'll have each group do one set of antacids, and then we'll take all the results on the board, and then we'll be able to see, oh, this antacid did 25 millimoles, another one did 30, another one did whatever, and then we can say, oh, this is the most effective antacid that we have at the whole lab, right? So it's pretty simple lab. The math is not complicated. It can be a little bit daunting to do titrations, but it's not too bad. It just takes patience and good technique. You want to be very exact with how much you're adding of each thing, and make sure your math is on point and use a lot of decimal places. Your significant figures are good. Right? So now again, if I didn't make it clear before when we were talking about this, this right here is our total moles of HCl that we added to the antacids. This is before we even titrate. We have this. To get how much was used by the antacids, we have to take this total number we added versus whatever was left over. And the way we get whatever was left over is the moles of NaOH that we added, because at that equivalence point, that's when they're the exact same because of the 1-to-1 mole ratio. If this was a 2-to-1 mole ratio, it would just be half, right? So hopefully this helps. Hopefully we can get a lot written in our notebooks and be ready to go when we show up on Monday for this lab. Very cool.